Welcome to solverfy.
.40. So we have a thin film of acetone, which has a refractive index of 1.25, sitting on top of a piece of glass, which has a refractive index of 1.5. This particular glass we're considering, different flavors of glass have different indices of refraction. And this is all sitting in air, so N1 is just 1. We see in the reflected light 600 destructive interference at 600 nanometers and constructive interference at 700 nanometers, fully destructive and constructive. And we want to find the film thickness, or the minimum film thickness. So there's an equation in the chapter, or two equations in the chapter, for maxima and minima for films that are surrounded with air on both sides. And they actually are going to be flipped or interchanged with each other or whatever. In this case, because instead of air on one side of the film, there's something with a higher index of refraction than either the film or the air. So our condition for destructive interference is now going to be 2L equals m plus 1/2 times 1 over n2. And constructive interference will happen for 2L equals m times, forgot a lambda here, sorry, m times lambda over n2. Which is not really, a problem. Is just you need to be aware that since we're given this for destructive and the situation is different than the one for having a film that's suspended in air, you just need to keep them straight. So putting 600 nanometers in for this, for lambda, we get 120, 360, 600, 840, 1080, etc. nanometers. This one putting in 700 nanometers for the wavelength for constructive interference. We get 0, which is not the case because we're told that there is acetone there. 280, 560, 840. And we can just stop here because we see 840 is the smallest number that's in both lists. So the thickness of our acetone film is 840 nanometers. Or this is the smallest thickness it can have, at least.